So for this week, as you can see in my previous video, I am approaching the videos a little bit differently and doing the picture diagram and then going into the exercise that I did. So I'm going to do this for the next 1 or 2 videos, and then we're going to introduce car talks where I am directly describing what I did. I'll be in the gym or I'll be in the car right after a workout. And I'm going to introduce new concepts every week to keep it interesting and entertaining and relating to the workouts that I'm doing. And just so you know, I typically wait till about the end of the week after I know each new concept introduced so I can relate it to the workouts that I've done for the week. So today we're introducing lactate. Sore or not? So lactate is introduced in the body when we have worked to a rate that we are working in an anaerobic state and our body is trying to catch up for the movement that we are doing. So basically, our body goes through the phosphocreatine cycle, and we've gone over that in the previous videos. I'm writing down the formula just for the sake of everyone being on the same page in what I am discussing. And then from there, the energy system of glycolysis. So I'm going to do a quick overview so then we can introduce lactate for what we're doing. Okay. So that's when we start with glucose, and we go through our 13-step cycle. We have our 2-pyruvate, which is a 3-chain link molecule that then gets turned into acetyl-CoA. Now we're getting into the Krebs cycle. To then ETC. I'm going to draw the diagram so then we can keep the picture theory here and puzzle piece everything that we need to together. So glucose, we make the pyruvate, right? So when we go through glucose, we have ATP that's put into the synthesis and reactions. We have 2 ATP that are put in that creates ADP, and that's why we only have 2 ATP as the net generation. And then we also have NADH go through here. So when our work rate is exceeding our work capabilities in movement and what we're doing for exercise, there's going to be a backup of hydrogen during ETC. And then with that, there will be a backlog of electrons with an electron transport cycle. And then ATP will not be able to be made fast enough for what we are doing with this aerobic cycle. So then when that all occurs, the NADH that is backlogged from the Krebs cycle, which we have 3 NADH and 1 FADH created through the Krebs cycle, they begin to then be pushed back over to glycolysis, where then the pyruvate introduces lactate. So the NADH and the pyruvate make lactate, and the lactate goes to the liver to make glucose, and then we have the lactate cycle through, in short, taking out the liver, cycle through the glycolysis to then continue making ATP to energize the body through its movement. So, in short, when ETC is backlogged, NADH gets sent to glycolysis to push lactate through glycolysis to make more ATP.